All right, the next thing we're going to look at is what happens when our data is nonlinear. And when we do that, we have to deal with logarithms. So we're going to do a quick little logarithm review. Before we do logarithms, we need to know exponents. And this exponent rule, when I multiply these, we add the exponent. So here x is 8. And here we have the same thing, same base. So our x is 16. When we're taking an exponent to another power, instead of adding, now we're multiplying. So this would be 3 to the 8th power now. Not 3 to the 6th, 3 to the 8th. So we'll do that again. Now it's going to be 3 to the 28th. Hopefully you remember those rules a little bit. Now when I say simplify it, in AP Stats, we're going to have to break this down. So there's a way that we'll be able to break this down. Since we're adding up here, it's like we're multiplying these two different bases together to get here. So we're going in the opposite order. Now I can simplify this by taking 5 to the third, which is 125, and 5 to the fourth, which is 625. And that x we didn't do anything with, so that stays in the exponent. So this is the same thing as that. We're going to need to be able to make that transition when we're dealing with this, with these logarithms. So you try this one. Hopefully you do 3 to the first times 3 to the 6x. This just becomes 3. 3 to the 6th. I do not know that answer. I should take out my calculator. 729. So 3 times 729 to the x power is our answer. Now, last one. I think you get the point by now. All right, let's do this. If I take log base 2 of 8, that's saying 2 to which number is equal to 8. Hopefully you know 2 to the third power is equal to 8. So that's what a logarithm does. It undoes exponents. Here we have 3 to which power is equal to 81. 3 squared is 9, 3 to the third is 27, so 3 to the fourth gets us to 81. If we don't have a base down here, the assumption is that it's 10. So 10 to which power is 1,000? Well, there's 3 zeros, so that would be 3. It's log base 10 of 100. There's 2 zeros, so that's 2. This one is like 1/10th would be 1 decimal. 1/100th would be there. 1/1000th would be here. This is the same thing as saying log, this is 10 to the negative 3. So log base 10 to 10 to the negative 3 would just be negative 3. Now if I want to solve this using log base 10, we could do it log base 2, but let's do log base 10. If I take log of both sides, the x comes out in front. And so when I divide by a log of 2, I just take the log of 32 divided by the log of 2. And with my calculator, I can take the log of 32 divided by the log of 2. And our answer is 5. Now, you should have been able to find that without it. Our goal is to understand this process to get down here. So if we want to do that using base e is a natural log. So we can do the same thing, and it doesn't change our answer or our process. It's still going to be natural log of 32 over natural log of 2. And when we type it into the calculator, now we just do ln rather than log. 32 divided by natural log of 2. And we still get 5. So don't be scared if it's a natural log problem or if they tell you to use log base 10. It's the same system. And we could also do a log base 2, but we're good now. Now, this is more what we need to do. We'll get equations that look like this, and we want to simplify, and so it just has a y equals in it. So what we have to do is the opposite of logging, which is 10 to the power. So I'll take 10 to the power of log y and 10 to the 3 plus 4x. And when we do this, we just get a y out. Now we simplify this right side, being 10 to the third times 10 to the 4x. And 10 to the third is 1,000. 10 to the fourth is 10,000. And that x stays up in the exponent. Usually, it's not going to be that pretty. It's going to look more like this. So when I take 10 to the log of y equals 10 to the 3.1526x times 10 to the 1.7924. Now this one, since it has the exponent, I like to write that second. So this becomes y. I like to write the thing that's the number first. So let's take our calculator. 10 to, there is a button, or you can just push it, but second log is the 10 to the. So we can do 1.7924, and that gets us to 62. And then this one is 10 to the 3.1526, which is 114.21, and then the x power. So now we took something that was written in a log, and we turned it to so there's not a log in it, and makes an exponential. A lot of times, instead of x and y, you're going to have actual values in there, a height and weight, for instance. So you do the same exact thing. 10 to the log of height is equal to 10 to the 1.876 times weight times 10 to the 0.7924. This just becomes height. This I like to write first because it's the actual number. So I'll go 10 to the 0.7924. That's 6.2. And this other one is 10 to the 1.876. That's 75.2, the weight. All right. I think we're good with that. Now, it gets a little bit more difficult if there's a log on both sides. Not any more difficult, I should say. I should just say a little different. So when I take log of both sides, or I take 10 to the power of both sides, I still do times 10 to the 0.7924. And I still reduce this to being height. And I reduce this to being, oh, I forgot my 6 up here, I just noticed. All right. So when I plug that in, I got 10 to the 0.7924, and that's 6.2. And now here, when I take, I want to get rid of this log, so I'll take 10 to the log of weight, which just becomes weight. Now, since I'm 10 to the log of weight cancels each other out, that 6 is still stranded up in the exponent. So it looks like this. So now it becomes a power equation rather than an exponential. Here's another one. So if I take 10 to the power of each side, that was not legible. So this becomes height. Oh, I forgot to put this down. That's times 10 to the first. And so 10 to the first is just 10. 10 to the log of weight is just weight. And then that 2 gets stranded up in the exponent. All right, now there's a worksheet associated with it. Hopefully this taught you enough to do it. Good luck.